Now the next topic is directions of two vectors. For vector x is x1, x2, x3 and vector y is y1, y2, y3 are two non-zero vectors. If y1 over x1 is equal to y2 over x2 is equal to y3 over x3 which is equal to k, and if k greater than 0, then vector x and vector y have same direction, and if k less than 0, then vector x and vector y have opposite direction. That is, if ratios of component of two vector is same and according to negative and positive value, vectors have same and opposite direction. Now the second condition is if ratio of first two components, that is y1 over x1 is not equal to y2 over x2, and ratio of last two components y2 over x2 is not equal to y3 over x3, and ratio of last and first component, that is no two component, ratio of no two components are equal, then their directions are different. That is, x and y have different direction. Now the third condition is if first component of x and y vector is 0 and ratio of other two components is same, say k, then according to first rule, if k is greater than 0, then vector x and y have same direction, and if k less than 0, then x and y have different, opposite direction as discussed in first case, first condition. And in this case, if ratio of last two components is not equal as x1 and y1 is 0, then according to rule second, x and y have different direction. For example, we will do some question to understand this. But before this, we will learn what happened. That is condition number 4. If two components equal to 0, x1, x2, y1, y2, all our components are 0, then for the ratio y3 over x3, that is third component of two vectors, is greater than 0, then direction of vector x and y is same, that is in same direction. And if y3 over x3 less than 0, then vector x and vector y have opposite direction. And what about origin, direction of origin vector? That is origin, this vector has no direction. So it was all about the direction of two vectors. Now we will discuss how can we describe the direction of two vectors. For example, find the direction of two vectors as given below. So the first part is vectors are 1, 1, 1 coordinate and with component 2, 2, 2. So we can see, we can check x1 over y1, or we can check is as like this: 2, 2, 2 is 2 times vector 1, 1, 1, that is y1 upon x1 gives 2, y2 upon x2 is 2, y3 upon x3 is 2. So it is k times vector x, as k is equal to greater than 0, then by the condition 1, vector 1, 1, 1 and vector with component 2, 2, 2 have same direction. Now we have to check second vector, that is 1, minus 1 and 2, and vector 0.5, minus 0.5, 1. So in this case, if we have 1, minus 1, 2 can be written as 2 times of 0.5 minus 0.5 into 1, that is k times 0.5 minus 0.5, 1, that is k is equal to 2, greater than 0. So by the first condition, given vectors have same direction. Now the third one is 1, 0, 0 and 0, 1, 0. So here there is no direction that k times this vector. We can't represent this vector as k times this. Just let this vector is k times this vector, for k is not equal to 0. Thus, by equality of matrix, 1 is equal to k into 0, that is 1 is equal to 0, which is not possible. Therefore, y1 over x1, y2 over x2, there is no two ratios are same. Therefore, vectors have different direction. That is by condition 2. So by judging in this way, or by taking the ratio of vector, we can judge how can vector have different direction, that is in same direction, two vectors are in opposite direction, or they have different direction. Now we will discuss problem based on unit vector. Find the unit vector along the vector u with coordinate 6, -7, 6. So here we have to find a vector, unit vector along the vector this. So first of all, we have to find the magnitude of u, that is under root 6 square plus -7 square plus 6 square. That gives 36 plus 49 plus 36. So that gives under root 121, which is equal to 11. So as we know, the unit vector in the direction of u is vector u over magnitude u, as done in theorem 2. So vector u is 6 minus 7 6 over magnitude 121 under root 21, that is 11. That is 6 minus 7 6 over 11. So unit vector in the direction of u is 6 over 11 minus 7 over 11 comma 6 over 11 as the component. Now the second problem is that find the unit vector in the direction opposite to the direction of vector x minus 2y. Given that vector x with coordinate 4, 7, minus 2 and vector y with coordinate 1, 2, 2. So in this, as we have to find unit vector in the direction opposite to x minus 2y, so first of all we have to find a vector x minus 2y. Let its name be u. Vector u is vector x minus 2y. So we can find vector x is 4, 7, minus 2 plus minus 2 times vector 1, 2, 2. So we get 4, 7, minus 2 plus minus 2 minus 4 minus 4. That is, we get 4 minus 2 is 2, 7 minus 4 is 3, minus 2 minus 4 is minus 6. Now the question becomes simple as we done earlier. We have to find magnitude u. That is under root 2 square is 4, 3 square is 9, 6 minus 6 square is 36. So we get under root 49. As magnitude is a positive quantity, so we will take plus 7 as a result. Therefore, the unit vector opposite to direction of u is minus vector u over its magnitude. As it is opposite direction, so minus sign indicates the opposite direction. So it becomes minus of, that is 2, 3 minus 6 over 7. So the required vector is minus 2 over 7 minus 3 over 7 plus 6 over 7. So this was all about the unit vector in the direction and opposite direction to the given vector.